In this short video, I want to talk about how you calculate the pH of a weak acid and a weak base. In contrast to the previous video, Ka for the acid is not infinity, it's less than infinity, and Kb for the weak base is less than infinity. In this particular case, when you have a weak acid, this is what you expect the ionization equation to look like. And in this case, let's do two things. Let's let HA naught at the beginning of the before equilibrium is established to be 0.5 molar, and we'll let Ka be 2.5 times 10 to the minus fourth. As we've done before, set up an expression, an ice chart. Initially, we have only HA present. The change is minus X for HA, plus X for both H3O plus and A minus. At equilibrium, HA is 0.5 minus X, 0.5 being the starting amount, and H3O plus and A minus are plus X each. Again, for Ka, it's the product's concentration at equilibrium divided by the reactant, which will be x squared over 0.5 minus x. You can enter this into solver. Obviously, you have to take the Ka value and subtract it from the other side. When you put it in solver, you get x equals 0.011. X is actually the concentration of H3O plus. When you take minus the log of that, you get 1.95. So in this example, we have talked about how you calculate the pH of a weak acid. Now let's proceed and talk about how you calculate the pH of a weak base. Again, the ionization energy for a base is B, being the base, plus H2O goes to BH plus, B being a proton acceptor, plus OH minus. For a weak base, K is much less than infinity, and in this case I took a different value for Kb. It's 4.5 times 10 to the minus fifth, but I've kept B naught to be the same, 0.5. Again, set up an ice chart. The initial concentration of B naught is 0.5, the others are 0. The change is minus X for B, and plus X for both BH plus and OH minus. At equilibrium, you have a concentration of B being 0.5 minus X, X, and X. Setting up the same relationship, Kb is the equilibrium constant for this equation, so the products over the reactant. So it's x squared over 0.5 minus x equals Kb. If you put that in solver, you get x equals 0.0047. Now x is actually the equilibrium concentration of OH minus, so you can calculate the POH. If you calculate the POH, it's 2.32, being minus the log of the OH minus concentration, and pH is 14 minus POH, so pH is 11.68. So now we can calculate the pHs of both strong acid and bases and weak acids and bases. Thank you.